Hi and welcome. So continuing on my project for the customer, I've got a bunch more parts to make, and I was going to go through the Delrin parts next. That should be interesting because I haven't worked with plastic hardly at all. I've turned Delrin on the lathe once before and it turned really nicely, so I'm kind of looking forward to this. I've got 4 of these to make, 2 of each of these 2 parts, which are very similar. It's going to be kind of challenging. By the way, this is Randy Richards' scribe that he gave me. Very nicely made. Thanks again, Randy. And it's got a hollow section that's 1.25 inches, and the outer diameter is only 1.5. So that's leaving about an eighth of it, well, exactly an eighth of an inch aside, or 0.125. That's going to be really thin, so I've got some concerns about that. This chamfer is going to be a little bit interesting because it's pretty long, about an eighth of an inch, once an eighth of an inch chamfer. So I think that means depth. I'm not entirely sure what he meant. He wasn't overly clear about that. I don't actually have CAD drawings for this. I just have this kind of drawing. So I might have to ask the customer. And then finally, I've got these Delrin parts. It's going to be made out of square stock, and that'll also be really interesting. They've got a lot of different features. A lot of drilled and tapped holes going this way, drilled and tapped holes going this way, another hole going this way, drilled and tapped. Lots of drilling and tapping. I'm thinking I can do both of these parts, mill the center section out together and relieve this side also at the same time. So like cut a little ledge here and then go in and cut the final amount out. I'll do this at a later, actually I should probably start with that. Probably should mill this guy holding it vertically, then do these 2 pieces right here. Anyways, I'll figure that out when I get to it. The remaining parts are just 1 each, and they're all aluminum, 1/4 inch material. This one's got a lot of drilled holes in it. Not so many tapped, which is good. Tapped on the sides, which is going to be a little bit interesting. This 1/4 inch thick material. Another one with a pocket in it also should be interesting. Drilled and tapped on the corners, only one of those. This tiny little thin stuff. So this is, I got to relieve 1/4 inch stock down to 1/8 inch. So what I was thinking about doing is super gluing this guy, but I'll talk more when I get to it. So I got to make these parts soon for the customer. So I'm just going to head over to the lathe and start turning. Oh, before I head over there, the 1.5 inch diameter precludes me from using my Jacobs collets, which I really like. When I flip the part around, I'll be holding by this 1/2 inch section to do the relief of the inner part. So I'm going to start doing this part here because you've got to flat drill the bottom and remove all this material. And then I'll hold it by the 1/2 inch section, flip it around, and bore this out. I'll use a Jacobs chuck to hold the 1/2 inch section here. But unfortunately, these only go up to 1 3/8, so I can't hold the outer diameter. So this will be an excellent opportunity to use my 6-jaw chuck, because the bottom line is, the more places you make contact, the less force you have to apply at each place you're making contact, which means the less chance of deforming the material, which is always a good thing. Alrighty, so I got some 1.5 inch black Delrin loaded in here. And the first piece is just going to be experimental. I've got a carbide insert here that is for aluminum that's very sharp and a brand new tip on it. I know a lot of people are probably saying high-speed steel, but these are incredibly sharp, and I think they'll do an okay job, so we're going to give them a shot. I've got a high feed rate right now, so let's just see how that works. I know you can take pretty big bites with the plastic. As long as you don't get so hot you start melting things, you're probably good. That was a piece of cake. Oh, that's like glass. That's nice. Okay. So if I call this my X0, let's see if we can do 100 thousandths depth of cut. That shouldn't be a problem. And go back to longitudinal. And that was no problem. Let's try 150 thousandths. That might be a bit excessive. Boy, it's cutting like butter. .516, 0.516, so not even too much deflection, about 2/10 deflection. Even with this big feed rate, I'm still getting a great finish. I thought I was going to have to slow the feed rate down. Next up, we have to drill a 0.5 millimeter hole, half an inch deep. I'm sorry, a 5 millimeter hole, half an inch deep. So we're gonna center drill this, and then I've got to find my zero. So I'm setting my zero here because I don't want the point to go below half an inch. So now I've got that at zero. That's 21 thousandths though. So I dial in 21 thousandths and make that zero. So we're going to go in a half an inch. And we're there. Next up, we're doing the end mill. I put my 0.21 millimeter, I mean 0.21 inch, 0.021 inch shim stock in there. And that way we can go the proper depth. So we're shooting for 0.5. And the beauty is I've already pre-cut most of the material. So I'm hoping that makes the end mill cut a more accurate hole. That's what I'm hoping anyways. And there's the conical point of the end. And there we are. Hopefully that'll work out to be 0.196, which is 5 millimeters. So how do we test that? A 1968, so about 0.197. So let me grab a gauge pin. Alright, so here's my gauge pin set, and it's 0.1978, and this is a 0.198 pin, and there's just a tiny bit of slot. So I drilled a tiny bit oversized, but that'll be fine. I've got a reasonable amount of play to work with here. I think he wanted this close within a thousandth or two, and I should be within that. Let's see, if I go 0.199, yeah, that's really snug. So that's piston. So it's about a thousandth oversized. That should be okay. Next up, we got to part this guy off, and I need 0.625, so I went 0.65 roughly. I didn't try and measure carefully because I'm going to face off the other side to the final dimension. Kind of got to get the old plastic out of there. That's interesting. Stuff parts very nicely. It's about as fast as you can push it in for the most part. And that was it. One down, one to go. I'm going to have to take this part out, reverse it, and do the recess portion in another operation. But first I'll make the second part. So to measure the depth of or the length of this protrusion, it's supposed to be half an inch. This is a uni-mic, and it normally has another piece that clamps either a round rod here or a flat on it to measure against. But you can also take that off and use this flat face as a measuring surface. Hold it tight on here and just walk it in and be very gentle, and I'm a thousandth over, which will be fine. So drill and tap, and that'll be the second one, ready for the second operation. Here's what the uni-mic looks like assembled. I just unscrewed this part off of here. Right now it's measuring against the flat, but you can also, there's a V-groove in there, and you can put a small cylinder and like a gauge pin that it comes with, and you can use that to measure wall thickness of very small diameter pipes, and things like tubes and things like that. Very, very versatile tool, worth having. Here's the second part, just different dimensions. Still a flat bottom hole, but 375 this time, just parting it off. Now, isn't that fun? Don't you wish you could do that with some 304 stainless? All right. So I've been working on my set true chuck here because the first parts I turned in this were this outer diameter here. And now I flipped the part around and I want the outside to be concentric with the shaft. But these set true chucks, when you change diameters, will not repeat. So it was off by plus or minus 2.5 thousandths. So I loosened all the bolts around the periphery and then made new adjustments, and now I'm within less than 1/1000th all the way around, and then I gotta just snug it all up again. So remember, every time you change diameters with a set true chuck, if you want it to be concentric again, like a 4-jaw, you're gonna have to go and readjust every time. If you want to use it as a 3-jaw chuck with just more jaws, then you don't have to worry about it. Just know that you can't take your part out. But it's nice to have the option. All right. Yeah, it's less than 1/1000th. All right. We're going to face off the sides to total thickness, and then we are going to hollow this out, and that's the part that I think is going to be particularly challenging because the spec calls for about 1/8 inch walls. Well, not about, exactly 1/8 inch walls, almost 1/2 inch deep. So we'll see how this material performs. Alrighty, so we need to bore out the centers of these guys. And just so you know, the 6-jaw chuck is a set true, and when I went to the smaller, last time I was holding the outer diameter of this, so you can't just flip the part around, tighten it down, and expect it to be concentric, because with a set true chuck, you have to loosen the bolts around the side and recenter it for each new diameter. So I did that, and I got it. It was off plus or minus about 2.5 thousandths, and now it's down to about a little less than 1/2 thousandth. I need to find my zero because I got to bore out the inside of this, which might be a little bit challenging because it needs to go in 4/10 of an inch. This is 0.625, and it needs to go all the way out to about 1/8 inch wall on this. Well, not about, exactly 1/8 inch wall. So anyways, we're going to pre-drill the center, and I'm going to start with a drill. I'm going to switch to an end mill to get a flat bottom so that I have room for the boring bar. Although this material is soft enough, I probably could just plunge the boring bar right in, but we're not going to do that. So I've got my zero set here. Now I need to move in another 21 thousandths to compensate for the thickness of the shim stock. And if you're wondering why 21 thousandths rather than say 25 or 20, it's because I'm at the mercy of the eBay, and I just bought what was available. So that's the size that was available. So we're going to go in 4 thousandths. One important recommendation is with an end mill that's a square corner like this one, or sharp, do not put the shim stock in front of it and tighten down on it, because if you do, those little corners that are very sharp are very fragile, and they can break off pretty easily. So I've made that mistake in the past. That's how I know to tell you, don't do it. Okay, there's my zero to compensate for the shim stock. We're going to go in 400 thousandths. And as I recall, I did a test piece before this, and I actually recorded it, but once you get in past a certain depth, it starts to load up, so you got to clear chips. And that's it. Now we've got our hole for our boring bar. One of the beauties of plastic is you can see how a big a bite this is, and it's really not a problem. You can just plunge right in. Okay, so there are a bunch of ways that I can find this thickness now. So now that I'm getting close, I need to measure the inside diameter, and there's a couple ways you can do it. The ideal way to do it would be to have a 3-point contact intra-mic, but those are insanely expensive, and I don't own any of those. So a couple other ways to do it is to use telescoping gauges like this. The problem with telescoping gauges, besides the fact that it's a very shallow hole, is that the final diameter I want is right at the limit and the transition point between telescoping gauges. I don't understand why they don't cross over more. So this telescoping gauge goes up to 1.125, and this one starts at 1.125. They should have crossed over. So one should have gone to like 1.5, and the next one should go down to say 1.25. That way you got a 25 thousandths overlap, because when you're right at the limits, it's really hard to get an accurate number. But this is about 48 thousandths is what that's measuring. Another way to do it is to have a tube mic. Now the problem with mine is I bought this used on eBay as the Michutoyo, but they usually would include specs of how small a diameter these can safely measure, because that's based on the radius of this carbide anvil on this side, and I don't know what that is. I could be below that limit. So the tube mic, you put the curved part on the inside of the tube and the flat part on the outside, and that gives you wall thickness. And since I know the final wall thickness needs to be 1.125, so there's a couple thousandths difference between the two. This one is saying I have 40 thousandths, and the other one said 42. Fortunately, I don't have to be hyper accurate. If I did, I'd probably need to buy an intra mic that has 3-point contact. You know, if the client, that's what the client needed, and then I have to charge a whole lot more. Fortunately, this is pretty loose tolerance. So we've got about 40 thousandths to come off, so we will try that. All right, so this is the finished part, and just so you know that the tubular mic, also another challenge because this is plastic. When you're tightening it down, my friction thimble is, or ratcheting thimble is broken on this. So I'm going by feel, but it's really easy to compress the plastic. So this says that it would be 4 thousandths under, but when I use the telescoping gauges, I'm 0.5 thousandth under. So I'm well within spec. So we're going to go with that. Last procedure on the lathe here is to chamfer these sides. All right, so next up, we have to chamfer the inside edge at 45 degrees until it comes right to the outside edge. By spec, it should be a really sharp point. I'm going to try and come just short of it. And the way I set my 45 is I've got my 45 angle block here, and then parallel right to the face of the chuck, right on the carbide, which is not straight with the cutter, and locked it down. So we're going to use this like a form tool, and we're just going to come straight in and put a 45 chamfer on it. One thing I did do to help me out here was I took my cutter and I lowered it below center, so that, because it's actually tilted down, it's a negative rate cutter, and so I brought the whole cutter so that all the way back to the midpoint is below center, because I didn't want to risk having it rub on the bottom of the cutter, the relief not being enough. So anyways, I think we got it pretty good. All right, so I'm starting with the first one here, and you can see it's my test piece. Although it's a perfectly working part, I made one to carry through all the operations, just see if it's okay. So I put a couple parallels in the bottom to set my height. Height is not really relevant to anything other than I just want to hold the part in place. A V-block would be very hard to hold this and still have access to get the drill bit in there. It's plastic, so it's not going to fight me very much. I'm using the outside of the jaw here to set my zero this way so it'll be repeatable. I have 2 more of these parts after this one to do. I'm going to go halfway in, and I'm going to center drill. first. And then that's going to be followed by drilling, and then I'll tap over at the workbench and deburr. And that's it. I'm also only squeezing very lightly because I don't want the part to pucker up, make the whole oval. Next up, I have to make 2 of these parts, also out of Delrin, which should be fun. Although plastic is kind of my nemesis because dimensionally it's really difficult to keep it in check. So I'm going to be curious if I can pull this off. So the way this is laid out here, this is 1 inch this direction, so I could make 2 of these parts side by side here. They're 1.2 long. This is a little bit over 1.2, and this thickness here is supposed to be 0.65. This is 3/4, so I can get it out of this. But that slot that I got to cut here, that's going to be difficult if I have to do each piece individually. I'm sure I can do it, but it seems that it might be easier to try a different orientation. So I have this piece here, and with this piece, so if I lay it out like this, then I can do the slot right through here, and it'll save me some trouble. I can do all the slots at once, and the material will support itself, which is kind of nice. And I can do that little relief there as well. So I'm probably going to try that and see how that works. So we're going to go with this piece, see how it works out. I have a feeling I might be making this piece more than once, but we'll give it a shot. We're going to try an end mill with aluminum inserts. They're not brand new, but they're still pretty sharp. Let's see how they work. Oh, look at that. That cuts really nicely. Smells kind of gross. And makes statically charged chips. That's going to be a lot of fun too. Oh yeah, that's a really nice surface finish. Normally when you're trying to square stock, you would stick something that's softer than the metal you're using. Typically I use copper in here to hold the part. But plastic is so soft, if I put copper in here, it would push into the plastic. So I'm trying cork. I don't know if that's going to work, but we're going to give it a shot, see if it holds well enough. So I found out it really wasn't very square, even though it had been dimensioned by someone else. So I'm in the process of squaring it up. So far this thing's holding its dimensions really well. So I'm trying to get my Y0 here, because this part is going to be turned like this, and I'm going to do the one, except I'm going to do it this way. Here's just look at the back side, but I'm going to do this little relief here, this 50 thousandths depth relief. We just cut the relief, 50 thousandths deep, ½ an inch wide. Alright, so the original drawing shows a chamfer on this edge, and I realized I can do the chamfer while the material's still here. I know there's not much light over there. It's just trying to make the drawing easier to see. So I can put the chamfer in here with all the support of the material around it. Might be difficult later. Also what I did was I redrew the part in CAD in a format that is very similar to the layout, so rather than have to mentally translate, I got all the dimensions relative to the size. Plus he didn't carry screw holes through to multiple parts, multiple portions of the part, so I show where they're going so I can tell. And you can see how weird this part's gonna be. It's gonna have screw holes going up very thin sections of this. It's gonna be kind of interesting. But I can do this chamfer now. So it's 700 thousandths over from this outside edge, 50 thousandths deep. So we're just going to do it. Should be really quick and easy, and I won't have to worry about chamfering later. That should be perfect. Part was brand new. It did a really nice job. A little bit of burrs at either end, but other than that, absolutely perfect. All right, so next we're going to hollow out this section, and we're going to use an end mill to do that. All right, setting up for this next shot, I've got my quill down a little bit so that I can have more visibility for you watching this. Normally there's a saying that I've heard says use the quill to drill and the knee to mill. Basically says this is for drilling. You should always leave it up and locked when you're not drilling, but this is plastic, not a lot of forces involved here. So we're going to try and hollow out the next section. We'll probably take some pretty decent bites. Leave room for a finished pass. This is a brand new end mill, very sharp. Looks like I could have taken a much bigger bite. We'll try 150. Surface finish is really nice. Now we'll do a 200 thousandths pass. Last pass, starting to cut into the chamfer, and this is before I do my final pass. I'm going to do the final depth on this outside portion here, and then I'll come back when I'm doing this slot and I'll do the entire edge at one time. I'm 5 thousandths away from, and you can actually feel it here, which is kind of cool. Now we're going to do the final pass, bottom and back all at once. It's only a couple thousandths on the back and 10 thousandths on the bottom, so it's not much material. So here's the final part, profiled, and I still have to run an end mill across this side to flatten it out, cut off the size of the part that I want a little bit larger than I'm going to need, run an end mill over the other side to get the final dimension thickness for 2 parts. So I'm going to run an end mill off each side to get 2 flats, cut it sort in the middle, and then remove material as needed. But that makes it sort of fragile, the profile that I've left here. And that was a risk I was taking because I was trying to get all the difficult profiling work done at once. So the chamfer came out perfect and really nice. The ledge came out really nice. All of these other parts came out really nice too. The flat bottom, look how clean that is in there. That all came out really good. So hopefully I'll be able to clamp on this without distorting it too much and breaking it. And then I just got to drill a bunch of holes and do some tapping. So with the rough dimension parts, well, they're actually dimensioned every way but the thickness right here. So what I've got to do is take them down. I cut them, saw cut them about 0.8. So I've got to take off some material. Alrighty, so we had to drill holes in the back of it that go down these thin sections for 632 taps, so we got those done. I set up 2 parallels in the middle to support the middle of this and then pinched it in the sides. Next up, we've got to drill a hole through the top here, very close to this end. I've got my work stop to set my zeros sitting on a couple parallels. There's nothing supporting the bottom, but this is plastic and it's a through hole, very light. Now we got to put this tiny drill bit, this 16th inch drill bit. They want 0.375 inch minimum. I'm gonna give him 0.4. All right, so here's the group of parts I made for that guy. 3 out of aluminum and 6 out of plastic. He actually wanted 1 of each of these for the first order, but there was an economy of scale of making more than 1, and in the second order he wanted the remaining made, so there was no reason not to. They were all challenging in their own ways. Plastic is kind of interesting to work with. I've got a couple burrs I got to clean up there before I pack them up. But here they all are, they're done. And interesting tip, if you need to hold plastic in the vise to dimension the stock, and you need something softer than the plastic to compress against it, if the because the plastic is not already square, use a cork. Have yourself a bottle of wine, and you'll be good to go. All right, thanks for watching. Hope you found it useful. Hope to see you next time.